Hi there. It is time for section 4-6, Isosceles Triangles in Geometry. So notice the directions here say, or the objective says, to use the property of isosceles in equilateral triangles to solve problems. I don't know if you remember way back in, I think it was section 4.1, we said isosceles was at least two congruent sides, so either 2 or 3. So that's why isosceles and equilaterals fall in together. If we're going to label the triangle, I remember doing this before. So remember, we've got ourselves a base. Base is the bottom, usually, but remember, base is the side that is not congruent to the other two. The two congruent sides are the legs, so I could mark those as congruent. And then the vertex angle is the guy up here. So vertex angle. And then the base angles are the angles that are along the base where the legs connect. I'll mark those guys with a double arc. So base angles. The only reason I want to say that is sometimes in a word problem I might say, oh, I've got an isosceles triangle, the legs are, and so you need to know that those are the two congruent sides. So just a little bit of refresher on those things. So let's talk about a couple things. There's an isosceles triangle theorem and then the converse. Basically, converse means backwards. We're doing it one way and then the other. We do this a lot in geometry. So this one says, if two sides of a triangle are congruent, then the opposite angles are congruent. So hopefully you notice in that top diagram that side AC and BC are congruent because they're marked with the congruent dashes. So if AC and BC are congruent, then that means that the opposite angles, so opposite from this one is angle 1, opposite from this side is angle 2, so angle 1 has to be congruent to angle 2. I see a lot of setup for equations for that. So maybe they'll have it marked just like that. Without the congruent angles, it'll just have the congruent sides, and they'll say, oh, well, angle 1 is equal to 2x plus 15, and angle 2 is equal to 3x minus 21. You'll need to know that angle 1 and 2 are congruent, so you'll set those expressions equal to each other. The converse goes the opposite way. If the angles are congruent, then the opposite sides are congruent. So if two angles are congruent, then the opposite sides are congruent. So basically, I notice in that bottom diagram that angles 1 and 2 are congruent. So, and they're marked with the congruent arcs. So that means that angles 1 and 2 being congruent, the opposite sides, side EF and side DE, have to be congruent. DE is congruent to FE. So if I know that two angles are congruent, I know that I've got myself an isosceles triangle because those opposite sides must be congruent. So if the sides are congruent, then the opposite angles are. If the angles, then the opposite sides are. Hopefully you can see how some algebra problems are going to happen with these things. Anytime they're congruent, we know we can set them equal to each other and solve. So name two congruent angles and two congruent segments. So, and not the ones that are marked, obviously. So if I asked you in this bottom triangle, I'll put this triangle ABC. If I asked you to name me two congruent triangles in triangle ABC, hopefully you can block out this part, put a little piece of paper over it or a sticker or some sticky note or something like that. I'll take that out of there. If I just look at triangle ABC, I see that side BC is congruent to side BA. Therefore, the opposite angles have to be congruent. So angle C has to be congruent to angle A. I got that because I blocked out half of the diagram, and you know, we could have said two congruent angles are going to be angle D and angle C, but those were obviously marked. If I ask you about two congruent segments in triangle BCD, that means I'm going to block out this bottom I've got myself two congruent angles, right? In that top triangle, angles C and D are congruent. So the opposite sides have to be congruent. So opposite from angle C would be BD. Opposite from angle D would be BC. So BC has to be congruent to BD. I do want to make sure that I mention that one side BC already had a congruent symbol on it, a congruent dash. So now that we know that DB is congruent to BC, and we knew that BC was congruent to BA because they were already marked, we could do that, eliminate the middleman. DB and AB have to be congruent to each other. So that's that transitive property. The first one's congruent to the second's congruent to the third, the first and third are congruent. A little sidetracked. All right, so here's a good chance for us to set up a problem. Hopefully this one is, actually let's go to number 3 instead. Let's skip 2. In isosceles triangle DEF, angle D is the vertex angle. If the measure of angle E is 2x plus 40, the measure of angle F is 3x plus 22. Find the measure of each angle in the triangle. So the first thing, if you don't know me yet, I'm going to need to draw a triangle. So make sure you draw if you have a word problem. I need a diagram. So isosceles triangle DEF. Ooh, better not label that yet. D is the vertex angle. It is telling you something about how you have to label the D, E, and F. If D is the vertex angle, remember the vertex angle is the one that's not congruent to the other two. It's the one where the two congruent sides come together. So I'm saying those guys are congruent. So D has to be at that intersection. So then E and F, it doesn't matter which side they go on, as long as they go somewhere on those base angles. It says the measure of angle E is 2x plus 40. The measure of angle F is 3x plus 22. So hopefully that isosceles triangle theorem makes sense to you. I don't technically know that E and F are congruent unless I remember that since DE and DF are congruent, the opposite angles have to be congruent. So angle E has to be congruent to angle F. So therefore, 2x plus 20 has to be equal to 3x plus 22. I can solve that equation pretty quickly. I'm going to subtract 2x and minus 22 from both sides. That's going to give me 18 equals x. Am I done with this problem if I know that that x is equal to 18? It said to find the measure of each angle. So angle D, angle E, angle F. So if I know that angle E is 2x plus 40 and we just figured out that x equals 18, I'm going to plug that in there. So 2 times 18 is 36 plus 40. I think that's going to come out to a 76 for angle E. No problem, right? What should angle F come out? Are you going to check your math or are you going to just trust it? If I put an x in for that, or an 18 in for that x, 3 times 18 is 54, plus 22 is 76. Does it make sense to you that angles E and F both came out to 76? We said they were congruent, right? So they should come out to the same number. So now how are you going to find out angle D? We don't have anything else about angle D, but we know that old-fashioned triangle sum theorem. What do the 3 angles of a triangle add up to become? 180 degrees. So if I know that I've got 76 here, 76 here, let me write that in there. I could add those two guys together and subtract from 180 to figure out what angle D has to be. I believe that's going to be, what, 152? So 180 minus 152. I think that's going to be a 28 degrees for angle D. Double check me, let me know if I'm wrong. So sneaky little word problems. And we've got ourselves an equation and we can figure out what happens there. So Let's talk about a couple equilateral triangle things. They're called corollaries. Don't worry about memorizing corollary 4.3. Please make sure you know that a triangle is equilateral if and only if it's equiangular. In other words, equilateral means equal sides. Equiangular means equal angles. So all sides and all angles are congruent. Equilateral. All sides and angles are congruent. Corollary 4.4 takes that one step further. I wish I didn't have these little degrees in here. If we knew that all the sides are congruent, which means that all the angles are congruent, and our triangle sum theorem tells us that the three angles of a triangle add up to 180, I've got to split that 180 evenly between those three angles, right? So what does each angle have to be? 60 degrees. Each angle of an equilateral triangle is equal to 60 degrees. Because they have to be equal, we have to split that 180 equally in three. So let's do one problem. Let's do letter B. Find the value of each variable. Letter B says, I've got x's and y's. What do you want to find first? So x equals and y equals. So notice, what kind of triangle is this? It looks to me like it's isosceles, right? I've got those two congruent dashes. So that means probably maybe we could find y first. So if I've got these two congruent dashes, wouldn't you agree that the 4y minus 2 has to be equal to the 2y plus 2, right? Because it's equal, or because it's isosceles, those are congruent. So 4y minus 2 equals 2y plus 2. So let's solve this guy. Subtract 2y from both sides. I'm going to add 2 to both sides. I'm going to get 2y equals 4. Hopefully I did my math right. How do you feel about a y equals 2? Does that look about right to you? So easy peasy. The sides are congruent. Letter B is an interesting, or sorry, the x's on letter B are an interesting one. So we do know this is isosceles, right? We know that those two legs are congruent. We can use that triangle or isosceles triangle theorem to say, okay, well, these two angles are congruent. So if the angle, the base angle to the right is 6x plus 8, that means this angle right here has to be 6x plus 8. Now your first thought might be, oh, I'll just set those two guys equal to each other. 6x plus 8 equals 6x plus 8. But that's not going to get us anywhere, right? If you look at this, it's just a true statement because if I minus 6x from both sides, I've got no x's left. If I subtract 8, I got nothing. So that's not a good option. So what we're going to have to do is use the triangle sum theorem. And some people did this a little bit different. And if you did it a little bit different, I'll know what you're doing. So I said that all three of those angles, so the 6x plus 8 plus a second 6x plus 8 plus 80 has to be equal to 180. So we can solve that then. 12x plus 16 plus 80 equals 180. I'm going to combine these two like terms right here. So 12x plus 96 equals 180. Subtract the 96. What's that going to be like? 84. So x, I believe that's a 7. I've got myself a value of x. I could plug things in there and check. You may have been a person who said, all right, well, if I'm using 80 degrees for this angle right here, that means I have 100 degrees left to split between those two base angles. So maybe you're a person who said, well, each one of those 6x plus 8s has to be equal to 50 degrees. If you solved it that way, you're still going to get a 7. So both ways are absolutely correct. And as long as you show me your work, you're good to go. Some people think I took the long, hard way to solve that one. So we're going to work on some problems. We're going to use isosceles and equilateral triangles to set up equations and solve for variables, and you have to know some sneaky things. So that is it for section 4.6 and chapter 4. Hopefully you're feeling good about the sections in this chapter and different ways to see congruent triangles as well as equilateral and isosceles. Have a good one. We'll see you next time.